Hey everyone, in my last video I talked about the synthetic call generator that we mentioned as the input for my last video. Well, we didn't go into it in that video, but I want to take a few moments just to talk about the small little app I vibe coded to help build synthetic calls to a call center so that it could go into the previous video's input stream, which was to redact the audio. So I needed some source files and I didn't want to actually use customer data. So what did I do? I used a couple different tools to build this synthetic transcription and audio generator. As you can see here, it's Python based and it's pretty simple to get going. So let's take a look at it. The first thing we want to do is clone this repository here. So you'll clone this and you'll use your terminal of choice, but git clone would be this. That command will give you a directory called ccproj if you didn't change the default cloning behavior. And it gives you 3 separate folders here, front end, back end, and the generator itself. The first thing we want to do is take a look at the back end to get it going. And once the back end starts, we can start the front end. So let's take a look at the back end here. You're going to notice a couple of things. First, there is this env file, and this is going to have all of your credentials and endpoints for the call generation, because we're using a couple of AI models, principally OpenAI, to create these synthetic transcripts and audio for us. So let's take a look here at what that is. So if you notice here, I'm going to blur out a few of my keys here, but there are a few things that you'll need, endpoints that follow these conventions here. Batch audio is for future use. I wanted to use the batch audio API rather than the real-time API to make this generation a little bit faster, but it's not in use today, so just keep it false. Make sure your API keys for OpenAI and the endpoint are here. I'm using GPT-4.1, and at the time of this recording, I'm using this API version here in 2024, end of 2024. So the other thing we have to do, and it's mentioned here in the directions, is setting up the requirements. So if you don't have Poetry installed, you can do a quick pip install R requirements. And again, it's going to read this requirements file and install everything it needs to install. You can optionally put this into an environment and run it only in an environment. That's up to you. But this will run through the installation and enable Poetry to be used. And see there are a couple of updates there to some of my different wheels that I had already local to my machine. But once this finishes, we're going to start up the back end, and then we'll start up the front end, and we should be good to go to generate some calls, both audio and transcripts. All right. And I'm just going to ignore the error, not a big deal. The next thing we want to do to start this is to run this particular Poetry command here. And this Poetry command is going to run the backend for us on that port, 8080. And you're looking for this startup complete here. And I'm going to reuse the same terminal window, and I'm going to follow the front end setup here. We're going to change to that directory again. Instead of the back end, we'll go to the front end. Oop. Need to make sure I'm in ccproj first, and then Contoso front end. There we go. So to get things going here, you need to make sure you run npm install. I've already run this command, So it shouldn't take long to run through this. It'll say everything's already there. And now we're going to run the package manager to run the front end. So now you can have your mouse over this, hold down Control, and it will open up the front end here. Now the front end is going to call the back end, and we'll actually see this in action here in just a moment. I'm going to slim this down a little bit and put this over here so you can see these two things happen side by side. We'll go back to the back end to see what happens when I click Go. So we're going to simulate patient visit, caregiver inquiry, and provider inquiry here. And we're going to keep the sentiment mix as random. So we'll have a mixture of negative, positive, and neutral calls that are simulated. We'll make these short, and we'll generate 3 from all 3 of these types of scenarios. So let's click Go. If you see on the back end here, what we're doing is we're calling the Azure OpenAI, and it's going to build files for you. And these files will eventually get stitched together to generate one big file in the local directory in your Git repository. So we'll wait for a moment while this goes. And while we're waiting, just a couple of things to call out here. We're generating WAV files in PCM codec at 16 kilohertz. That is the recommended audio file for us to use later on in the transcription and redaction pipeline that's in the other video here. Just to recap here, we have this call center app is generating our WAV files and transcripts. We just care about, in this particular, the other video, we do all the redaction and all that fun stuff over here. But all we care about out of this app for me, personally, for my devices, was to use the audio files that are generated here. All right. So we see we have one file generated at 78,000 milliseconds, and the channels and sampling rates are all the same here as they match out here. And you see I have a file call to with the time date stamp. So let's go to our local directory. And you'll see here it's in the backend / generated audio right here. Backend generated audio. And here are the files generated today. Here's that timestamp, and here are the file names that match up there. And the third file just finished because I saw the website button finish here. So I should have 3 calls, 1, 2, 3, generated here, and I can look at the output at the back end, 1, 2, 3, and we're good to go. Now when I want to pull down or bring down the server, all I have to do is hold down Control and press C, and the back end will stop, and Control C will back out of the front end too. So if I hit reload here, I should get nothing. It's going to say, hey, I can't find anything because we just brought down the server. Okay, that goes over generating. So let's hear what the output of this synthetic call is here. So let's pull.
Good afternoon. Thank you for calling the Patient Support Center. This is Shannon speaking. How may I assist you today?
Hi Shannon, this is Dr. Anderson from Contoso Specialty Center. I'm calling regarding a recent patient encounter, and I'd like to verify some information from the visit.
Absolutely, Dr. Anderson. I'll be happy to help. Could you please provide the patient's full name and date of birth for verification?
Yes, the patient's name is Robert Guzman, date of birth October 4th, 1975.
Thank you, Dr. Anderson. And do you happen to have the patient's ID number for additional verification?
Yes, I have it here, CTM 666873.
Perfect, thank you. Could you also confirm the date of the patient's visit you're referencing?
So as you can see, the call is pretty detailed. It goes through a scenario that a call center at a hospital system or hospital payer might experience with a physician calling in to verify some information about a visit. The other scenarios are in place as well, and you can listen to what's generated there. I have specifically put in synthetic personally identifiable information and personal health information, PII and PHI, in the output of the WAV files for me to redact later on, again, referencing the other video that I posted last month. If you have any questions about this synthetic generation or you want to modify this for your own scenarios, feel free to fork this repository and have at it. Thanks for listening, and if you have questions, please send me a message on LinkedIn or put a comment on the video below. Take care. Have a nice day.